Station, this is Houston. Are you ready for the event?
Houston, this is Station. We are ready for the event.
Metropolitan Arts Institute, this is Mission Control Houston. Please call Station for a voice check.
Station, this is Metropolitan Arts Institute in Phoenix. How do you hear me?
Hello, we hear you loud and clear. How do you hear us?
Very well, thank you. Thank you for speaking with us today.
It's a real pleasure. We're glad to have you on board. Welcome to Expedition 34.
We'll get started with the questions. Andrew?
Hello, my name is Andrew Kendall, and this question is for Chris Hadfield. What do you consider the most vital component in an astronaut's skill set aboard the ISS?
The most vital component in an astronaut's skill set. For me, I think it's competence. The fundamental key that everyone counts on everyone else for is competence. When it comes right down to it, you have spent the time, you've done the homework, you've practiced, you've got the skill set inside so that you can do the required work as necessary. Everything else is good, but without competence, we're setting ourselves up for real problems.
Thank you.
Hi, my name is Felix, and my question is also for Chris Hadfield. How does zero gravity affect how you play your guitar?
Hey, thanks for the question. I just happen to have brought my guitar with me right here. This is a nice standard acoustic guitar, 6-string, metal string. The difference, of course, is you don't need a strap because it just floats in front of you. The strings behave about the same, but it can resonate really well because it's not deadened against your body, and it sounds about right here. We'll play something. So it sounds all right. As you see, though, as I'm playing it, I kind of need to brace it against my body a little bit because the guitar wants to float around. And if I want a bar chord, then I've got to stabilize the guitar. But you get used to it, and it's nice not having to carry the weight around your neck. And it's just wonderful to be able to play guitar as another human way to try and understand this incredible new experience of leaving the Earth.
Thank you.
Hi. My name is Sam Proctor, and this question is for Tom Marshburn. Evidence shows that after a time in space-like environment, a human's height can be stretched a few inches. Have you experienced this or other general changes to your body due to zero gravity?
Well, you've been doing your homework. That's true. Our bodies do stretch. Our spinal columns elongate. The little cushions between the bones get more fluid in them because gravity's not squishing them down. So we don't really feel it. Some astronauts get a little bit of back pain from the muscle stretching from that effect, but we don't really feel it. But just a couple of weeks ago, we checked to make sure we fit in our seats, our Soyuz seats, to make sure we can still fit in them when it's time to come home. So we still seem to fit very well. So you have to measure it with some kind of measuring device to notice that. But yeah, you feel lots of changes in your body. Our legs get skinnier. Our gastrointestinal system, our stomach and intestines have to get used to it. So we're back to normal as far as that goes just after arriving here. But then you feel fluid in your head, and that never really goes away the whole time. So you feel that change as well. But other than that, your body is a wonderful machine. It's capable of adapting really well. We're going to feel a lot of the changes again when we get back to Earth, and we'll have to readapt.
Great. Thank you very much.
Hello, my name is Sarah Prince. My question is for Chris. Do you ever feel overwhelmed or intimidated by the deep vastness of empty space just beyond your window?
That's really interesting question. You would not believe, Tom and I have both been outside on spacewalks. where you put on a suit and go outside. And that's probably where you feel that profound feeling more than ever, because it's just you alone in the universe. And you're in between the Earth pouring by on one side and everything else, all the blackness on the other side, and you're maybe just holding on to the space station with one hand. But for me, it wasn't at all scary. It was hugely exhilarating. It was just a fantastically rewarding experience to be able to be in between those two things, like literally with your body, but also sort of historically, as we are starting to leave Earth permanently as a species living on more than one planet. And these are the very early steps. So for me, every time I look out there, just fills me with a great sense of wonder and excitement at the things that you're going to be able to do in your life.
Thank you. Hi, my name is Amelia Atterbury. My question is for Chris Hadfield. What is a mistake you've made aboard the ISS, and what did you learn from it?
Amelia, I was taking pictures with one of these cameras, and we noticed in all of the images that there was a little bit of dirt, like a little speck on the picture. So I thought, okay, time to clean the camera. So I got at the procedure and got this special pencil sort of thing that you reach inside. You actually touch the sensor in the camera. And it's, you don't want to scratch the sensor. But I could see some dust that had floated onto it. So I opened up, very carefully reached in, super expensive cameras, and they're how we photograph everything. I reached inside, I touched it, and it left a great big scratchy smear on the sensor. And I thought, oh, what did I do? So I tried again carefully, thinking maybe I just put something on there, and it made it worse. And I just had this horrible, if your stomach could sink without gravity, I had like a stomach sinking feeling. So I stopped doing what I was doing, and I went and talked to our commander, who's Kevin Ford, and said, Kevin, I think I've wrecked a camera. I feel terrible. But he said, no, wait, let me have a look. And he's had more experience. He's been up here longer than I have. And he looked in, he got the pencil in, he realized you could touch it a little more, got another pencil that we had, or it's really a little, we call it a pencil, but it's a special cleaner. And that helped clean up, and it was really just sort of some residue I'd put in there. I hadn't really scratched it. So the day was saved, and what I really learned from it was, one, be careful what you're doing, follow the procedures. Two, ask for help from other crew members. And three, even when something looks bad, it's probably not as bad as you think, and you just need to work together and solve it. So it was a good lesson for me.
All right, thank you.
Hi, my name is Scarlett Bickerton, and I'm speaking on behalf of Alexa Rose. To the both of you, what are your favorite space-related movies?
All right. Well, when I was 9 years old, so a good bit younger than you, I went to see a movie. You may have heard of it. You may have actually seen it. It's called 2001: A Space Odyssey. I think if you saw it today, you'd think it's a little bit funny, a little bit strange, and maybe a little outdated with the special effects. But at the time, it was at the cutting edge of special effects. Actually, a lot of space movies nowadays still draw from the techniques that were used in that movie. And it filled me with a sense of wonder. I didn't understand it, but I remember the visual images impressing me very much. After that movie, my favorite planet became Jupiter. And the whole idea of being in space, of being away from the Earth in the deepness of space, was something that became ingrained in my psyche and something I wanted to find out more about ever since then. Chris?
For me, there's lots of movies that are like anything that you know a lot about. When you see a movie, often they get all the details wrong, and it kind of spoils it for you. But for me, the best one is Apollo 13. They came and they spent time with us in Houston and in Florida. They really tried to get the details right, and I think they did a great job of telling the story of space flight and of what it's like to be an astronaut in some tough circumstances. I think Apollo 13 is also a really good space movie.
Very cool. Thank you.
Hello, my name is Jared Romero. My question is for Tom Marshburn. What are some basic space laws put in place for those serving aboard the ISS?
Well, it's a good question. We actually do have a series of laws. We call it a code of conduct between international countries. Now, keep in mind that countries have gotten together to decide who is going to be on the space station. We can't have all countries represented all the time, so that's a complicated plan that's brought up. And then on top of that, you have a commander. And so that commander could be from any country. And those commanders have to hand over one to the other as we switch crew to crew. So there are very specific laws as to who's in charge, that is the commander, and what modules people are in charge of that they're specifically taking care of. The Russians, in general, take care of all the technical details on the Russian side. The U.S., we have the U.S. lab and our other modules. Columbus would be a European astronaut, and the Japanese Kiba, where we are right now, Japanese module, typically would be a Japanese astronaut if they happen to be on board. And Chris, as a Canadian, will be the first Canadian commander on board the space station when we start Expedition 35. So this is a series of complicated laws to make sure we know who's in charge and to know what our responsibilities are. And it's all written down. We've got it all worked out. It seems to work pretty well.
Thank you very much, Tom.
Hi, my name is Jack Morris, and my question is for Chris Hadfield. If any form of simulated gravity was created, would it benefit the ISS, and if so, how?
Yeah, Jack, we actually have artificial gravity on the space station. We have centrifuges. For a lot of the experiments, you actually need some gravity. Like if we're doing blood work, you need to spin the blood so that the heavy particles settle to the bottom so you can do the science right. So we have small spinning centrifuges in our science racks on board so that we can do some certain types of things. But one of the biggest benefits of the space station is that it doesn't have gravity. You can do things here that are impossible to do on the Earth, and that's what most of the experiments do. So to have gravity would kind of just make this a regular laboratory and not a unique laboratory for all of humanity. It might make our lives a little easier if we had gravity, but if you ever tried flying in weightlessness, you'd realize that even though there's some disadvantages, the advantages outweigh it. It is such a constant treat to be weightless that I'm really pleased that we haven't figured out artificial gravity yet, and that we have the chance to be weightless for months and months. It's just, it's like a toy that never winds down, or like a present that constantly unwraps. It's lovely being weightless.
Thank you.
Hi, my name is Joseph Magulad, and this question is for Tom Marshburn. What experiments have you participated in that you think have most benefited the ISS and general space travel?
You know, that is a really difficult question to answer because all of them play a part in benefiting space travel, which ends up benefiting humankind as well. You know, Chris and I have done a bunch of experiments. On material science, developing new materials, those will probably play a part someday in not only Earth-based applications, but for space flight and new spaceships. We've got all kinds of experiments on the outside being bombarded by the sun and by cosmic rays and radiation, and they're testing the hardening of those materials for spaceflight applications. I'm a medical doctor. I'm a little bit biased. I think the most important thing we've figured out is how to keep humans healthy on board the space station. We have wonderful exercise devices, both resistive and cardiovascular exercise devices. We've been able to maintain our bone and muscle like we've never been able to do before, so there's almost no loss of bone at all. And so we're extending the capability of humans to live in space so that we can go out for long, long periods of time, maybe a year or longer, to an asteroid, moon, Mars, or even beyond that. So that's what I would say.
Hi, my name is Ethan Kraft. Chris, what everyday activities on Earth are much more complicated on the ISS?
Yeah, Tom and I were talking about this earlier, in fact. A lot of things that are easy on Earth are hard here, and things that are hard on Earth are easy here. But just simple stuff. I mean, you want to wash your hair. It's more brushing your teeth. You don't have a sink. You don't have running water.
Tie your shoes.
Tying up your shoes is hard. Like just picture if I want to tie up my shoe and I start doing on one shoe, and then suddenly I'm floating away across the room and bouncing into things, and so stuff you take for granted, stuff that you need to have a stable body for, those are hard. The simple, mundane ways of life. preparing food is complicated. You know, often when you're preparing food, you add a little salt, little pepper, some spices, put a little cheese, fry this up, throw it, cut up, grate up things, peel things. All of that creates waste and stuff floating all over the place. And normally when we eat one thing at a time. So you heat up your vegetables, you start your vegetable, you finish your vegetable, you throw it away. Then you get your meat, and you do that because it's hard to keep 4 packages open at once. So all the little stuff, eating, doing up your shoes, all that. But one thing that's really cool, when you put your pants on here, you can put on your pants 2 legs at a time.
Hi, my name is Taylor Capon, and my question is also for Chris. How long do you think it will be until we can travel to the moon like we travel between different countries?
You know, I bet people were asking that exact same question 100 years ago about airplanes. You know, airplanes were pretty new back then. They were safe enough, but they weren't like airlines yet. And most people that flew airplanes then were taking a chance and had to be specially trained, and there were a lot of risks involved. Just 100 years ago, just like one long human lifetime ago. And people were probably asking, when can we get in one of these things and, you know, fly from London to Paris or fly from Phoenix to New York? When can we actually do something with these things? And now look at it. You don't even think about it, right? That when you get on an airplane, you kind of mostly worried about whether they feed you and what movie you might see. You aren't worried about the technology anymore. And the reason we made that transition was because of human inventions. We went from high drag, very rickety engines in through to low drag. And NASA's predecessor did a lot of work on it, making airplanes streamlined, and engines. Engine technology was the big change, coming up with reliable jet engines. And that's what we need to answer your question before going to the moon is like taking a trip across the Atlantic. We need, I think, the next level of rocket technology for engines. Because right now to get us here, we can do it, but it's hard to keep it safe. And therefore, it's still very complex and expensive and takes years of training. But I think a couple generations of invention of rocket technology, hopefully someone there in Phoenix right now is thinking about it. What could we do different? Come up with a new invention so that not only could you guys come and live and work on a space station, but get to the moon pretty quickly, just as we've learned to travel all around the surface of the Earth.
Thank you.
Hello, my name is Daisy Pinkley, and my question is for Tom Marshburn. Do you find that your natural reflexes are lacking after returning to Earth?
That's an interesting question. Yeah, the way I would answer that is to say my natural reflexes change when I come into space. I think it happens to all of us. So they would have to change again when I go back to Earth. For instance, the reflex when you want to throw a ball. On Earth, if you want to have it get some good distance, you have to throw it up a little bit so it makes a big arc. But in space, it's completely different. So we are now used to being able to throw things slowly and carefully, but in a straight line. And that's a natural reflex that's going to have to change when we get back to Earth. A number of astronauts tend to go with their natural reflexes sometimes for the first few days and drop a lot of things. I know after my shuttle flight, I dropped a couple of glasses of water. So those reflexes that work just great up here are going to have to change again when we get back to Earth. And so, yeah, our natural reflexes will readapt when we get home.
I'm going to hand it back to Ms. Meztek now.
Hi, my name is Izzy Ramos. To Tom Marshburn, have you or anyone you know suffered from physiological after effects from being in space?
A lot of physiological effects, yes, but also perhaps some psychological as well. And one of the things people will have to do is once they've been away, is not just unique to space, but for anyone that's been away from their family for a long period of time and their friends, is to readapt. You know, my family has been having their own lives and doing wonderful things on the Earth. We miss each other. We keep in touch a little bit. But when I get back, I'm going to be integrated back into the family, and it's going to, you know, maybe take a little while for them getting used to me being around again. So that's probably the most difficult psychological effect. I don't know there have been profound effects, although, having a chance, as Chris was describing, to look out and see the blackness of space, to get just an inkling of our place in the cosmos is a very profound thing. And I think over the years and years, I know after my shuttle flight 3 or 4 years ago, I've always thought about that, what the space looked like and what the Earth looked like from our vantage point. And that's actually a wonderful psychological effect I wish everyone in the world could have. We might reduce a lot of our problems on the Earth if everyone could see that. So those are the effects I anticipate when I get home.
Right. Thank you. I'm going to hand it back to Ms. Mestick now.
Thank you so much for taking the time to speak with us today. This has been a wonderful experience, and we really appreciate all of your answers.
Thank you very much. I wish Kevin Ford could be here with us, but from Chris Hadfield and Tom Marshburn and Expedition 34, it's wonderful talking to you. Thank you.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you, Metropolitan Arts Institute and Students Station. We are now resuming operational comm.